So this was a Pop Quiz 7, MCQs Pop Quiz 7. If you have any question or doubt in the first one, question 1, any doubt? Question 2, any doubt? Question 2, any doubt? Okay, in question 2, the question is when 50 cm cube of a hydrochloric acid of concentration 2 mole per dm cube is added to 50 cm cube of a sodium hydroxide of concentration 2 mole per dm cube, the temperature increases by 13 degrees. The experiment was repeated using 25 cm cube of the same hydrochloric acid and the 50 cm cube of sodium hydroxide solution. What is the temperature increase? So first thing, look, we have the formula that E is equals to Cm delta T, where specific heat is constant. So what is the relation between the temperature change and energy? But like if I further simplify this formula, I can write E divided by Cm equals to delta T. Now, C is a specific heat. C is a specific heat which is a constant for the solution. So what is the relation here? The relation is relation between the energy and the temperature change. It is directly proportional. And what is and how energy is related? Energy is related to moles. If you use more moles for a substance, we'll have a greater amount of energy release and there will be a greater change in temperature. And it is inversely proportional to the mass. If you use a large volume of a solution, specific heat capacity is a fixed value. You don't have to calculate in this one. It will be 4.18 because we always use the water, the specific heat. But here we don't have to calculate. We just have to use the theory here. Like without formula, you can solve this question. So how to do such question? So what is the total volume of the solution used in the first experiment? 50 cm cube of a hydrochloric acid and 50 cm cube of a sodium hydroxide means the total volume of the solution was 100 cm cube. If the total volume of the solution was 100 cm cube, it means the mass of the solution. If you use 100 cm cube of a solution, it means the mass of a solution is 100 gram. So it means in the first experiment, we use 100 grams of the mixture. Because we have the formula that E is equals to Cm delta T or E divided by M into C is equals to delta T. The relation. Now, 2 moles in 50 cm cube and 2 mole per dm cube. So like the concentration is 2 mole per dm cube for a hydrochloric acid as well as the sodium hydroxide means we are using the same moles. So if we are using the same moles for each of them, so they will completely react with each other. So they will completely react with each other. There will be no limiting factor as both reactants have a ratio 1:1. And because of this, the temperature change was 13. Now the experiment was repeated 25 cm cube and 50 cm cube. So what is the volume in second experiment? So total volume in the second experiment is 75 cm cube. If the total volume is 75 cm cube, how much mass will be there? It will be 75 grams. And so this is a change in the mass. Like it was 100 grams first, but now it is 75 grams in the second experiment. What about the moles? If you compare the moles for the second reaction, which will be the limiting factor? The limiting factor will be a hydrochloric acid. Why a hydrochloric acid will be a limiting factor? Because we are using the same concentrations, but 50 cm cube of a sodium hydroxide and 25 cm cube of hydrochloric acid. So for the second experiment, the moles which will react will not be same. The moles which will react will be half. So the relation between the energy, the mass, and the temperature change, if we increase the moles, the energy will also, the temperature change will also increase. If we decrease the moles, the temperature change will also decrease. And the relation between the mass of the solution and the temperature change, it is inverse. If you use a smaller mass, it will have a greater change in temperature. So when we compare the mass of the first experiment we use 100 grams, 100 cm cube or 100 grams. And the second experiment, it was 75 cm cube or 75 grams. By what factor the mass has changed? If 100 become 75, by what factor the mass has changed? What number I should divide with 100 so I get 75? So what does it mean? Means this has decreased by 3 by 4. So what is the relation between the mass and the temperature change? They are inverse. So if the mass has decreased by 3 by 4, because if 100 is multiplied by 3, if you have 100, it is multiplied by 3 and divided by 4, you will get 75. So if the mass has decreased by 3 by 4, what will happen to temperature change? The temperature change will increase by 3 by 4 because they have an inverse relation. There's an inverse relation between the mass of the solution and the temperature change. And so due to the change in the mass, the temperature will change by 3 by 4, multiply by 3 by 4. And what about the moles, the relation between, because if I use greater number of the moles, that I will have a greater change in temperature. So mole and temperature change are directly proportional. In the first experiment, we use 50 cm cube and 2 mole per dm cube. But in the second experiment, we use 25 cm cube and the same concentration, 2 mole per dm cube. It means the moles have become half. So what will happen? The moles have become half. So if the moles become half, if the moles is divided by 2, what will happen to temperature change? The temperature change will also be divided by 2. So in short, relation between the temperature change and the moles, it is directly, and the relation between the temperature change and the mass is inversely, the mass of solution. So the first experiment, we use 50 cm cube, 2 mole. The second experiment, we use 25 cm cube and the same concentration. So if we divide, because this will definitely have half moles, if the moles are half, the temperature change will be half. And what happened to the mass? Like what happened to the mass? Like example, if 100 is there, multiply by 3 by 4, so that will become 75. So if the mass, if it become like multiply by 3 by 4, so what will happen to temperature change? It will always be inverse, so it will be divided by 3 by 4. Is it clear till this point? The relation between the mass and temperature change? Or you can also, like example, if I have 100 divided by 1.33, like in terms of fraction, if you find it difficult, you can also use a decimal here. Like if I have 100 and 100 becomes 75. So how 100 can become 75? So means 100 should be divided by 1.33. Because if I divide 100 by 1.33, I'll get about 75. So if the mass is divided by 1.33, so the temperature change will be multiplied by 1.33. So due to the change in the moles, the temperature change should be divided by 2. And due to the change in the mass, the temperature change should be multiplied by 1.33. So originally the temperature change was 13. So 13 multiplied by 1.33 divided by 2. What's the answer for this? 13 times 1.33 and then divided by 2. So we got C, or 8.7 degrees. 8.465, which is 8.7. Why we multiply here? Because as you can see, there's an inverse relation between the two quantities. When two quantities have an inverse relation, it means if one quantity, because as you can see, the mass is divided by 1.33, like mass decreased by 1.33. So if the mass of the solution is decreased by 1.33, what should happen to the temperature change? It should increase by 1.33, as they have an inverse relation. How we know when to take a reciprocal of a quantity and when to take example temperature or mass? How you know that this is a fixed relation? That we have the formula that E is equals to Cm delta T. So energy is specific heat into mass equals to temperature change. So what is the relation between the energy or the moles? So moles and temperature change are directly proportional because they are both sides of. So moles or the energy are both sides on the numerator. That's why if one is multiple, it means they're directly proportional. Where the mass is in denominator and the temperature change on the other side is in numerator. So it means what is the relation between mass of a solution and the temperature change? They are inverse. So what actually happened is the mass, it was 100, it becomes 75. So how 100 can be 75? It means it is divided by 1.3. So because they have an inverse relation, so the temperature change should be multiplied by 1.3. Same thing, the moles become half. So if they have direct relation. So if the moles become half, the temperature change should be half. So the temperature change because of the change in mole should be divided, and because of change in mass, volume of the solution or mass, it should be multiplied. That's how we worked out. Is it clear discussion? Question 3, any doubt? Question 3, question 4, question 5. Question 5b. Chlorine is added to 2 cm cube of a dilute solution of a potassium iodide. The equation for a reaction between a chlorine and iodide ion is shown. So when the reaction is complete, 10 cm cube of a cyclohexane of a density 0.75 was added. Look, the cyclohexane is an organic solvent which is having a density of 0.7. And the mixture, this was what? This was aqueous solution. As you can see here, aqueous iodine is there. So when you mix the two solutions, what is the density of the water? The density of the water is 1 grams per centimeter cube. So if I mix a cyclohexane with a water, because the density of the water is higher, so water will be there at the bottom because of the high density, and the cyclohexane will be there at the top because of the low density. And because they have a greater difference in the density, so the two solvents will not mix with each other. From where the water came, as you can see in the question, the beginning, it is written aqueous, a dilute solution. Aqueous means, the term aqueous means it is mixed with water. Means this reaction happen or occur in water. That's how we got the water. So we have it is forming the two layers at the bottom. We'll have the water because the density of a water is higher. And at the top, we'll have a cyclohexane because its density is lower. Now, in the solution, as you can see, iodine is formed, like I2 iodine is formed. So you have to recall the color of iodine. What is the color of iodine in water or aqueous? Iodine having different colors, you have to recall these colors. When iodine is there in aqueous solution, means iodine is dissolved in water. In aqueous solution with a high concentration, it is brown in color with a high concentration. But when iodine is present in water or aqueous solution with a low concentration, it is yellow in color. So what actually happened in this reaction? Like first, there was a reaction between iodine and the iodine and the chlorine. There is the reaction between iodine and the chlorine. What it form? It will form iodine molecule and it will form a chloride ion. Right now, in the beginning of the experiment, because the water is there, so what should be the original color? The original color will be brown because high concentration of iodine, all iodine is present in the water. Then what we did, we add a cyclohexane. Say this is, we add a cyclohexane here. So when we add a cyclohexane, iodine can dissolve in both organic or aqueous solvent, like in water as well as in organic. So as a result, this iodine will move from the water to the cyclohexane. When this iodine moves from water to cyclohexane, the concentration of the iodine in the water decreases. As the concentration of iodine in the water decreases, what will happen? It will turn yellow. So the bottom layer, in this case, the color of the bottom layer should be yellow. Then when iodine is mixed with the organic solvent, what is the color of the iodine? The color of the iodine is purple. So iodine changes, like iodine in aqueous or in water, it is different color, but in aqueous it is different color. So as a result, what will happen when iodine is mixed in the organic solvent, what will be the color of the iodine? It will be purple. So that's why, and the upper layer will be purple. Why this is not acceptable? Lower layer is brown. Why it is not acceptable? Even though iodine is brown, but because the concentration of the iodine in water decreases, so this layer will turn yellow instead of brown. Is it clear? The reason for the change in color of the two layers? You have to learn the color of iodine in aqueous as well as in organic solvent. Question 6 or 7, any doubt? Question 6, okay. Going from calcium to barium, which property changes? We have calcium is there, then we have strontium, and then we have barium. As we go down the group, what will happen to ionic radii? Ionic radii does not decrease, the size of an atom increases, so ionic radii will increase. When we check the second option, first ionization energy decrease, that's correct, because like as the size increases, so it will become much more easy to remove electron from barium as compared to strontium. And strontium is easy compared to calcium. So this is the right statement. The melting point increase, no, for the metals, because the size of the positive ion increases, so the attraction, the metallic bond decrease, so the melting point will decrease, not increase. So why C is wrong? Because when we have like calcium is there, it will have a small positive ion. So it will have a stronger attraction in the metallic lattice. as compared to that of strontium. And strontium will have a stronger attraction as compared to that of a barium. So the melting point does not increase, the melting point decreases as we go down the group. And reactivity for the metals have a tendency to lose electron. So as we go down the group, reactivity increases, it does not decrease. Is it clear? Question 9, any doubt? 9, 10. Any doubt in question 9 or question 10? Ten B. If the final mixture of a gas is passed through a U tube containing a sodium hydroxide, what is the final volume of a gas in CMQ? A and B, okay. Look, remember one thing, like this is a combustion reaction. We have a butanol is there which burned completely. 7.4 grams of a butanol was burned completely in 16 cm cube of oxygen. The mixture of the gases produced cooled. What is the volume of the mixture of gases in dm cube at room temperature and pressure? First thing you have to, whenever two reactants are given, you have to identify the limiting factor or a limiting reagent. How to work out the limiting factor or limiting reagent? You have to first compare with the moles. So how many moles of butanol will be there? So that is 7.4 divided by the mass of a butanol, which is 74. So 7.4 divided by 74, we got 0.1 mole of butanol. How many moles we'll get? We have 16 dm cube of oxygen. So moles of a gas is volume divided by 24, which is 16 divided by 24. So 16 by 24. So it will be 2 by 3 or 0.6. So almost, as you can see, like if this is 0.1, this is also 0.6. So means there's a complete reaction. Burn, as they already mentioned, it burned completely. So means no reactant left behind. Now we want a product. So how to get a product? So what we can do, any one of the reagent or any one of the reactant we can use to work out the product. The final volume of the mixture of the gases. So if I take a ratio between a butanol and a carbon dioxide, what is the ratio between them? Oxygen is only accessed by like when you take it is like 0.66. So 1:6. So it's burned completely. Only 0.06 moles of oxygen are in access. So how we can work out? We can simply use the ratio. What is the ratio between butanol and carbon dioxide? The ratio is 1:4. So if we have 0.1 mole, so this will be X cross multiply. So we got 0.4 mole. This is the 0.4 moles of the carbon dioxide and the excess of the oxygen, like the part of oxygen which is left, because 1:6 is a ratio, we need 0.6. So how many moles of oxygen are left behind? 0.06. So what is the total moles of the gas which are left behind? That is 0.46. And 0.46 multiplied by 24. So we'll get the volume of the gas. So 0.46 times 24. What's the answer? 11.04. So we'll get B as a right answer. You will never get the exact number as like because it is 0.666. So if I use that number, I will get So we got the moles for oxygen, the total moles of the gas. Now, the if the final mixture of gases is passed through U tube containing sodium hydroxide. So sodium hydroxide is an alkali and sodium hydroxide is an alkali. So which substance it will react? It will remove the carbon dioxide. So moles of the carbon dioxide will be removed because acid can react with an alkali or acidic oxide can react with an alkali. Carbon dioxide is an acidic oxide. So it will react with sodium hydroxide. So carbon dioxide will be removed. So what we are left with? We are left with the unreacted moles of oxygen only. So how many moles of oxygen? Like the moles of oxygen which were left unreacted were 0.0666 recurring decimal. And the carbon dioxide moles when we use it was 0.4. But all these moles of a carbon dioxide are removed as it reacted with sodium hydroxide. So we are left with only the moles of oxygen, which is 0.066. Now 0.066, these are the moles. So 0.0666 recurring decimal. If I multiply by 24, how much volume will be there in dm cube? What volume will be there in dm cube? 1.599 dm cube. But we want answer in cm cube. So if I'll multiply by 1000 to convert this dm cube into cm cube, I'll get 1599. 1599 is approximately equals to 1600 because the sodium hydroxide will absorb all the carbon dioxide as carbon dioxide is an acidic oxide. So we are left with unreacted moles of oxygen, which were 0.0666 and recurring decimal was there. Is it clear? Any other doubt in this pop quiz, which was related to the MCQs? Then we have a structure pop quiz.